So you may notice that section 7.2 is going to look very similar to what we did in 7.1. We're still going to be dealing with systems of equations. However, what makes these systems different is they might not be linear equations. Last time all we dealt with were linear equations. And linear equations, again, the highest exponent you will see is a 1. Today, with nonlinear equations, you might see an x squared, which would then make it not linear. So all of our objectives today are going to involve nonlinear systems and the different ways to solve them. Now, the good news is we are still going to be focusing on the same two methods to solve them, substitution and elimination, and they work the same way. It's just since these systems are nonlinear, there's going to be a little bit more work involved. So, examples of what I mean by systems of nonlinear equations, these are two examples. Notice on this first one, this is a linear equation because the highest exponent is a 1, but the top guy is not a linear equation because I have a squared. So what we would actually see on this one, if we graphed it, we would see a line. And remember, the squared items, the quadratic items, make a parabola. On this other one, this top guy would make a parabola. But the bottom one, notice how there's multiple things squared. That would actually make a circle when it's graphed. So let's look at this first example here. I want to solve by using substitution. Now what I've also done is I've given you a picture of the graph. So you can notice we have a line and a parabola graphed. And we talked about last time that if you have the graph, the answer is the intersection. Well, notice since it's a line and a parabola, according to this picture, they are intersecting in two places. They're intersecting at 2, -3 and at 4, 3. So in theory, those are the two answers. Now, on the homework today, you won't be given a picture of the graph, but I just wanted to show you that so you can see what are we trying to find or what is actually going on when we find these solutions. So those should be the two answers that I get when I solve it algebraically. So since they want me to use substitution, remember substitution is where you get a variable alone. So I could get the x, the y, the x, or the y. I can get any of those four things alone. I would pick the one that takes the least amount of work. So the one that catches my eye is the y that's in the bottom. So if I want to get that alone, I would subtract 3x. Notice my y is still negative though, so it's like there's a -1 there, so I have to divide everything by a -1. So I get -9 plus 3x. Then remember, the whole reason why we get y alone is we are going to take that and we're going to substitute it into the y of the other equation. So I'm going to have x squared equals 2 and then -9 plus 3x plus 10. I've replaced the y with what I said y was equal to. And now we just have to solve this. So I'm going to distribute. Combine like terms. So -18 plus 10 is where I got the -8. Sometimes this is where people get stuck because they don't know where to go from here. Well, especially since I have something squared, something not squared, and an x term. If you have something that's squared, remember a few units ago we talked about ways to solve quadratics. You can factor, you can try square rooting, you can complete the square, or you can use the quadratic formula. I'm going to try factoring, so remember to factor, everything needs to be on one side. So I'm going to subtract the 6x over, and I'm going to add the 8 over. So I get x squared minus 6x plus 8, and I'm now equal to 0. That is what I would like to factor. Multiply to 8, add to negative 6. That would have to be a negative 2 and a negative 4. So if I solve each, I get x equals 2 and x equals 4. Now I'm not done because remember I said I want your answers to be ordered pairs. So I need their y coordinates. How do I get their y coordinates? Well, just like last time, we have to substitute our x values back in, and I would put them right into this equation where you got y alone. So let's first do the 2. So if I plug 2 in, I get negative 3. So what that tells me, as an ordered pair, one of my answers, when I plugged 2 in, I got negative 3 out. So there's one of the solutions. And now I'm going to plug the 4 in. And I get 3 out. So my other solution, when I plugged 4 in, I got 3 out. And notice these two answers are exactly what we saw on the graph. We are basically finding the intersection of these two equations. So really the only thing that's different about today versus last time is you might have more than one answer. It depends on how the items are intersecting. Okay, next one. We have a line and a circle. Now again, if we look at the graph, I can see exactly what my two answers are. One of them is 2, negative 1, and the other one is 0, negative 3. But on your homework, you won't have the graph. I'm just putting that there as a reference so that you know what we're finding. All right, so it wants me to do substitution again. So I would like to get something alone. So if I look at my 4 variables, it doesn't matter which one I get alone, I would pick the one with the least amount of work. And this time, the one that catches my eye, I'm going to get the x alone. Okay, you don't always have to get y alone, you can get x or y alone. So I'm going to get x alone because the only thing I have to do is add y over. So I get x equals 3 plus y. And it's ready to go. It's done. So I'm going to take that and substitute it into the x of the other equation. So instead of x, I'm going to have 3 plus y, and then my minus 2 squared, and my y plus 3 squared equals 4. So now I want to simplify and solve this. I would combine like terms, so 3 plus the negative 2, I'm going to write it as y plus 1. Now what I recommend doing, and sometimes we've had trouble with this, these items that are squared, I'm going to have to FOIL them out. So right above it here, I'm just going to write it twice as reference. So let's multiply that out. So first times first, y times y, I get a y squared. Outer times outer, y times 1 would be 1y. Inner times inner would be another 1y. And last times last, 1 times 1, would be 1. Okay, the next guy, I'm going to quick write it out twice. And we're going to FOIL that. So first times first, y squared. Outer, y times 3, 3y. Inner, 3 times y, another 3y. Last times last, 3 times 3, 9. And then I still have my equals 4. Okay, lots of like terms to combine here. So a y squared plus a y squared would be 2y squareds. We have 1y plus 1y plus 3y plus 3y. That is 8y. And then we have 1 plus 9 is 10. Since I have something squared, something not squared, and a constant, I'm going to try factoring, so I want everything on one side, so I'm going to subtract the 4 over. So we're now equal to 0. Now, before you actually set up your morphing, you could do something to this to make the numbers easier to work with. I'm going to take a greatest common factor out. I'm going to factor out a 2 to make the numbers a little nicer. If you don't do that, that's fine. You'll still get to the same answers. So now I can see I want to multiply to 3 and add to 4. So 3 and 1. So just keep that 2 out front. And now we're going to set each piece equal to 0 and solve. So I get -1. I get -3. Now this first chunk where I set 2 equal to 0, there's no variables there, and that doesn't make sense. So that's garbage. That doesn't give me anything. Okay, so remember, I want your answers as ordered pairs. So now what we're going to do is we're going to substitute these answers back in, and I'd put them back in way up here where I had the x alone. So one of my values I'm plugging in is a -3. So if I put my -3 in for the y, I get out 0. Now be really careful here that you write this ordered pair correctly. When I put -3 in for y, I got 0 out for x. In the ordered pair, the x coordinate is always first. In the ordered pair, the x coordinate is always first. Even though we found the y first, the x coordinate is still first. So there's one answer. Now I'm going to substitute in my other y value, which we said was -1. And I get out 2. So that ordered pair should be 2, -1. And there are my 2 answers that I saw on the graph. Okay, let's try another one. Now this time, oh my, look at the graphs here. So if I look at what's been graphed, how many answers is this one going to have? And you should be saying 4. They intersect 4 times. This one's going to have 4 solutions. And again, you won't have the picture of the graph, but I wanted to show you visually how something could have 4 answers. Now this time it wants me to use the elimination method. And remember, it's probably going to call it the addition method. So if we're using elimination, that means I want something to cancel out, either the x's or the y's. And to cancel out, they have to be the same number but opposite in sign. So on this one, I could either cancel my x squareds or I could cancel my y squareds. I would do the y squareds because they're already both 1's in front. I just need to turn one of them opposite. So I think I'm going to multiply the bottom equation by a -1. So I'm going to leave the top guy alone. But the bottom one is now going to be a -x squared minus y squared equals -10. So I can see when I add things together, my y squareds are gone. 4x squared plus a -1x squared is 3x squared. And on the other side, 13 plus -10 is 3. And now I want to finish solving. I would just finish getting x alone, so I'll divide both sides by 3. I get x squared equals 1. And then the last step, I'm going to square root. Now you should be yelling at me, I have forgot something. When you take the square root, make sure plus minus appears. So technically what's happened here, I do have 2 x values. I have 1 and I have -1. So now how do I complete my ordered pair? Well, we have to substitute them back into one of the equations. It doesn't matter which. I think I'm going to plug them into the bottom one. It looks like it might be a little less work. So let's plug 1 in first. And we're plugging in for x. So 1 squared is 1. I'm going to subtract 1. And then I'm going to square root. Now make sure when you square root of 9 is plus minus 3. So what does this mean? When I plugged 1 in, I got 2 y's out. So how do I write that ordered pair? Well, you're going to have to write it as 2 ordered pairs. So when I plugged 1 in, I got a positive 3 out. And when I plugged 1 in, I also got a negative 3 out. So there are 2 answers right there. Okay, so that plus minus, super important that you don't forget that or you're going to drop answers. I'm not done though, because I still have to plug my x of negative 1 in. So now I'm going to plug negative 1 in for x. Negative 1 squared is a positive 1. I'm going to subtract 1 over and square root. So I also get 2 y values out when I plug negative 1 in. So when I write these as ordered pairs, when I plug negative 1 in, I got a positive 3 out. And when I plug negative 1 in, I got a negative 3 out. So 2 more answers. So that is how we are getting 4 solutions total on this problem. All right, and this last one here, solve the system. Again, we're going to use elimination. If I look at the graph, I can see I'm only going to have one solution, 0, 3. So let's see mathematically how that would work out. Now, here's a common mistake when people are doing elimination. They'll say, ooh, I'm going to cancel the y's because I'll just give this guy a negative. You can't cancel those y's because they're both not y squareds or they're both not just y's. They have to be like terms, and right now one is squared and one isn't. So there's no way you're going to cancel the y's. Not going to happen. But I could cancel my x's because they are both x squareds. But before we do that, we kind of have to do a better job of lining things up. So what I'm actually going to do first is I'm going to subtract my x squared over because I need to line it up. So I still have 3 on the right side, and my bottom equation looks like this. Okay, so all I did was move the x squared over because I want my x's and y's on one side. And actually, by moving it over, the x squareds are ready to now eliminate. I don't have to multiply by anything. So they're gone. Now, here's another mess up that I will see. When you go to add the things that are left, you cannot add the y and the y squared. They are not like terms. So I can't say 2. How do I write that then if I can't combine them together? Well, they're just going to sit next to each other then. Okay, equals 12. So again, I cannot combine the y and the y squared. They're not like terms. They stay next to each other. So since I have something squared, something not squared, and a constant, I'm probably going to try factoring. So I want everything on one side. And I'm going to write it in order here. So I'm going to subtract the 12 over. And now we're ready to try factoring it. So I want to multiply to negative 12 and add to 1. So that would have to be a 4 and a negative 3. So I get negative 4 and 3. Well, that's really weird that 2 things are coming out because on my graph I could have sworn we said we only have one answer. Let's keep going and see what happens. So I have to substitute those back in. And again, it doesn't matter where you put them back in. Let's do the top equation. So I'm going to put my 3, oops. I'm going to put my 3 in and make sure we put it in for the y. I was going to put it in for x, but these are y's that we found. Okay, if I want to solve for x, I could subtract my 3 over, and then I'd square root. Technically, we'd get plus minus 0, but that's 0. So one of my solutions, make sure when you write the ordered pair, the x is first, 0, 3. And that's the one the graph is showing. So what's the deal with this other one? Let's see what happens. If I plug -4 in for y, because that was the other y I found, I'm going to subtract 3, and then square root. Technically, I would get plus minus I square root 7, because the negative under the square root would come out as I. It's imaginary. That's why you're not seeing that ordered pair show up on the graph. It's imaginary. You're not going to see it plotted. So that's actually a dead end. So I do only have one answer, 0, 3. So my biggest tip of advice for this section, please, 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 if you take the square root, you cannot forget the plus minus, otherwise you will drop multiple answers.